So students, now in this session I will explain question number 9 and 10 of exercise 3.3 chapter 3 understanding quadrilaterals. Now in question number 3 you see this figure. Okay, this whole figure is a trapezium. Now this trapezium is a combination of two parallelograms. Just watch it very carefully. You see the first parallelogram is K, R, I and S. This is one parallelogram. Fine. And another parallelogram we have E, C. This line you see E, C, L and U. These are the two parallelograms. This is one parallelogram, that is E, C, L, U, and another parallelogram is R, I, S, K. Also you can say risk. Fine. It is already given in the book. That is risk and clue. That is R, I, S, K and clue C, L, U, E. Clue. Now what do you have to find out? You have to find the value of X. Now before that, let me just rub this angle. Okay, rub this angle. Okay, it will be very easier for you to understand then. Suppose let us consider it on this parallelogram first. Now, angle K is given. Fine. So what is the relation between K and S? If I consider this parallelogram, so what is the relation between angle K and S? So they are adjacent to each other, isn't it? So what we have to write is that in suppose if I divide the board into two halves. Now in parallelogram RISK, okay, in parallelogram RISK, angle K plus angle S equals to 180 degree, isn't it? And why? Since they are adjacent angles, isn't it? Now how to get the value of S? Now we already aware of this angle, that is 120 degree. So in place of K we will put 120 degree plus angle S is equals to 180 degree. Now what we have to do? We have to transpose this 120 degree towards right hand side. Okay, so you get angle S as 180 degree minus 120 degree, that would be equals to 60 degree. Okay, so now we know this angle, isn't it? This angle is considered to be as what? 60 degree. Okay, so now this part is done. Now let's rub this part. Let's rub this part. Forget about this one. Now let's concentrate on this. Let's concentrate on this parallelogram. So what is the name of this parallelogram? So name of this parallelogram is CLUE. Clue. Now how these two angles are related to each other? Carefully see, these two angles. These are opposite angles. So in parallelogram, the opposite angles are always equal, isn't it? So you will write in parallelogram clue, angle L is equals to angle E, that is equals to 70 degree. And why I am saying? Since this opposite angle, since it is opposite angles of parallelogram. So we know that in parallelogram the opposite angles are equal. Fine. So now once we have done with this part, so now I will draw the two lines again. Here. So this is our intersection point of these two lines. So we'll consider this intersection point as 0. It is not given in the book, but consider this point as 0. Now this angle, what is the measure of this angle? Angle S is what? Angle S is 60 degree. So we'll write it 60 degree here. And what is the measure of this angle? 70 degree. So we'll write it here as 70 degree. Fine. And this we have to find it out. That is this angle we have to find it out. And this measures X. Now carefully observe this figure. This is a triangle, isn't it? EOS or SOE, whichever way you can write. Fine. So in triangle EOS, angle E plus angle S plus angle O is equals to 180 degree. We can write. And why we can write? Because angle sum property of triangle. angle sum property of triangle, isn't it? So now what is the value of E given? Not given, but what is the value of E? 70 degree. So what is the value of S? 60 degree. And what is the value of O? That is X, which we have to find it out. Now this is what? 130 degree plus X is equals to 180 degree. Now how to get the value of X? Obviously we have to transpose this 130 degree towards right hand side, isn't it? So X would be equals to 180 degree minus 130 degree. So that would be X equals to 50 degree. Okay. So this is a solution of sum number 9, students. I hope you all have understood the sum properly. Yes, now I guess it is totally visible. Okay, now we'll move on to sum number 10. So this is question number 10, students. So what we have to do with question number 10? So in question number 10, you have to prove that a quadrilateral KLMN is a trapezium. Now a trapezium is a quadrilateral in which you will have only one pair of parallel lines. Fine, only parallel lines. That doesn't mean that if those two lines are parallel, they should be equal. They are thus one pair of parallel lines. They just have to be parallel, not equal. Okay. So now we have studied according to the property of a parallel line. Now you just see this part. Suppose if any transversal line intersect any two lines, fine, intersect any two lines at a fixed point, suppose any fixed point out here, and the angle which is formed on the same side of the transversal, if the angle of these two measures 180 degree, if the sum of these two angles measures 180 degree, then only we will consider these two lines are parallel to each other. I repeat, that is, if a transversal line is intersecting the two lines in such a way that the angle formed on the same side, on the same side, isn't it? On the same side of the transversal line, that is angle 1 and 2. Okay, if the sum of this angle 1 and 2 is equals to 180 degree, then only you can say that this line, that is L1 and L2, are parallel to each other. So this is the concept. This is the concept that we have to use for question number 10. Fine. Now as you see, according to the figure, that these two angles are given, and we'll consider this line, that is ML, as a transversal line. So before we get the sum of these two angles, we need to write something. What we have to write? We have to write that when a transversal line intersect any two lines in such a way that the sum of the adjacent angles is 180 degree. Okay, if the sum of the adjacent angle is 180 degree, then the lines will be considered as parallel. Okay, so based on this logic, now we'll find the sum of these two angles, that is angle M plus angle L is equals to 180 degree, isn't it? Now that is what, no, not like this, that is 100 degree plus 80 degree, that is equals to 180 degree. Now as you see that the sum of the two angles is equals to 180 degree, so we can write thus MN is parallel to KL. So this quadrilateral is having one pair of parallel lines. And what did I say about the trapezium? That it is a quadrilateral in which we have one pair of parallel lines, isn't it? So we have already proved this. So we can write, therefore, the quadrilateral KLMN is a trapezium. Okay. No, KLMN has a pair of one parallel side, so it is a trapezium. I hope I have been right. The quadrilateral KLMN has one pair of parallel line, so it is a trapezium. Okay. Now this is the solution of question number 10, students. I hope it is clear to all of you. Yes, now you can see. So this is the solution of question number 10, and that's it for today's session. Students, thank you so much. God bless you all. Take care and stay blessed.